Good morning, everybody. Once again, I am here for with you with the same session, that is views and oscillation. And of course, the last point today we are going to discuss, and this one is the very smaller, the very small part, which is to be again related with your basic fundamental thing. And what we learn at the beginning, that is the characteristics, or the you can say the properties of the views are going to be there. It is again dependent with that fundamental characteristics. So in the previous session we have seen how the wave motions are there in the strings are to be there, and how the equation of the wave motion in the string is to be there. And today, dependent with that, the what exactly the frequency and the time period, that relationship we are looking forward as far as the wave motion in the string is going to be concerned. So let's move on. Again, myself, Dr. S.D. Chauhan, Department of Physics, Adarsh College, Singoli. Now, here the fundamental thing, as I already told you, that in the beginning session, introductory sessions, we have seen what is mean by the frequency and the time period. All that things are to be there. But again, as far as the frequency period of the vibrating string, if we want to find out, then first again we have to go for the basic fundamental things. I already told you that time also. Wherever the one view I can say, it is not as a simple single view is to be there. It comes with the number of things. That view with the that is to be comes, that is the generation of the view is to be the due to the vibrations. Repeated and periodic vibrations are there, and with that vibrations, the whatever be the wave is to be traveling, or wave is to be having itself with the amplitude, time period, frequency, as vibrations are there, and again to be your wavelength is also to be there. So all that parameters, the phase is also the same part related with the characteristics we can see. Now here are the frequency and the time period relationships as far as the wave motions in the string we are discussing. No doubt frequency, as it is defined with the number of vibrations per second. And as far as the time period, that is the for completing one vibration, how much amount of the time is to be required, that is for the one complete vibration is to be there, that is related with your time period part. And as the frequency and the time period relationships are going to be concerned, we are already discussed in detail the relationship also to be there, that it is always to be as an inversely proportional to each others are to be there. So in this case, the frequency in simple way is nothing but to be number of vibrations per second, number of cycles per second we can say. And as far as the time period, again it is the time required for the complete one vibration is to be there. And one resolution for one complete resolution, in that sense it is to be the half cycle, and half cycle it gives you the complete to be as in one circle, or one period is to be there, and that's why it is to be called to be as in time period is to be there. So as far as the string is going to be concerned, what are the changes as far as these fundamental things are to be there? So as we know that both the ends of the strings are going to be fixed, that is the two sides are going to be fixed. In that sense, the vibrations what are going to be created are nothing but to be plunk out this area, and you will get the vibrations. But what happens when I am plucking it out? What happens? The half wave will be generated in this fashion. If you look at this carefully, if you look at this carefully again, so half wave will be generated up to this point, and half wave will be generated up to this time. That means to complete one vibration, it has to travel from this point to this point, and this point to this point. Means for completing one vibration, the required the resistance is to be traveled, as far as for this wave is going to be concerned, it is half part this and half part this. That means it have to travel this distance, the length whatever is supposed to be having the L. In that case, it has to travel, the wave has to travel twice this whatever the string length is to be there. So in this case, the wavelength, that is wavelength is nothing but to be for completing one vibration, whatever be the distance traveled by that wave, it is nothing but to be your wavelength is to be there, and it is denoted by lambda. Now if suppose I am considering this length of the string is supposed to be small l, in that case the whatever be the lambda or the wavelength in this case for the string is to be twice L. Why it is to be twice L? Because it has to travel for completing one vibration. The wave have to travel from this to this, but it can't go forward because here is the fixed point. It return backs in this fashion, and that's why the whatever be the travel distance, it is twice the length of the string is to be there, and that's why in this case the whatever be the noted here, the lambda or the wavelength is nothing but to be twice L is to be there, as the length of the string is L is considered. Now in this case it is very simple to understand this part where it is to be as an why in the string the wavelength is going to be the twice the length of the string is to be there. So as again in the previous session or yesterday session we have seen in detail the equation of motion of vibrating string, and that equation of motion of the vibrating string is nothing but to becomes with the d2y by dt square is equal to t by m into d2y by dx square is to be there. If suppose this one is to be equation number 1 as far as the equation of the motion of the vibrating string. And if you look at this part as far as this another case where it is to be differential equation of wave motion related with that, again the differential equation of wave motion, it is having the similarities as far as the relationship is to be concerned. If you look at this case where d2y for this case where the differential equation of wave motion is to be there, d2y by dt square is equal to x square d2y by dx square. So if suppose this is to be as an your equation number 2 is to be there. Now in this case we are going to compare the equation of motion of the vibrating string and differential equation of wave motion is to be there. And if you compare this equation 1 and 2, you will find the left hand sides are already similar, that is d2y by dt square for the equation number 1, that is the equation of motion of the vibrating string, is similar as good as your differential equation of wave motion equation number 2 is to be there. So left hand sides of these two equations are equal, that's why right sides are also going to be equal. Now again in the right hand side what is to be similarities or equal part, d2y by dx square. In this part where it is to be in the equation number 1, if here it is to be similar, that is d2y by dx square in this equation number 2. Now what is the remaining part? The equality is to be there, only the remaining part is to be here to be as, and when I am comparing the equation 1 and 2, v square is equal to whatever be the t by m is to be there. So that comes with the new relation when I compare these two equations, equation number 1 and 2, that is the equation of the motion of the vibrating string and differential equation of wave motion, then I will get basically v square is equal to t by m is to be there. So here it is to be either it is the very small one, but you can see here it is to be there. The comparison will give me v square is equal to t by m is to be there when I am equating or comparing this equation 1 and 2. At that time I am getting v square is equal to t by m. Now again if I want to find out the only v, then I have to under root or the square root of this to be, I will get v is equal to under root of t by m, and that's why here to be as an if you look at this case where it is to be giving me v is nothing but to be simply is equal to under root of t by m is to be there. Now again we have to go back to see the relationships as far as the in the previous sessions also we have discussed in detail, that is the wave velocity, the relationship about the velocity, frequency and the wavelength is to be there. In this relationship, as we are aware about that v is equal to n lambda, where the v is going to be the velocity of the wave is to be there. Small v is nothing but to be velocity of the wave is to be there, n is nothing but to be the frequency, and lambda is nothing but to be your wavelength is to be there. So this is what the relationship we already discussed in the beginning stage. That's why I said the introduction of the waves is very important factor, because these fundamental things will definitely useful for understanding the number of things related with the waves are to be there. So v is equal to n lambda, where the v is small v is to be velocity of the wave is to be there. N is nothing but to be a frequency and lambda is nothing but to be a wavelength. Now here I can rearrange this equation and I can get the n is equal to, definitely this lambda will go to this way and it will become to be as an n is equal to v by lambda is to be there. So this is what the n is equal to, you will get v by lambda is to be there. But as good as our relationship for the string is going to be concerned, we already discussed that now, that lambda in this case, as far as the string is going to be concerned, it is lambda is equal to twice L. So why it is twice L? Because wave have to travel twice of this length to complete one wave, and that's why the lambda is twice L. And if I put these values for the string, because I am interested to find out the frequency related with the string, so n is nothing but to be v by twice L, this relationship I will get. So this is how this part comes to be, as an n is equal to v by twice L is to be there. So moving forward, as far as the frequency part nearly we calculated, and we put the values of both the things, that is to be v is to be there, v already we calculated, that is putting these values of v and your lambda, you will get the value for the frequency, and that is nothing but to be n is equal to 1 by twice L. If you look at here, it is the equation number 3, what it will give you, that is the n is equal to 1 by twice L under root of twice under root of t by m is to be the new relation for the your frequency part is to be there. So this is how the frequency is to be there. And as this frequency is for the lowest mode and for the smaller value, and that's why it is called to be as a fundamental mode is to be there, as it is for the lowest frequency value as the at this lowest frequency mode, that's why it is called as a fundamental mode is to be there. In the same case, if I want to find out the period for the same mode, that is the lowest mode is to be there, or fundamental mode it is to be said. So in that case, now what we know, that the frequency and the time period are inversely proportional to each other, and due to that what will happen, the t is nothing but to be, I can write 1 by here. The important factor is to be to understand the in general we can write for the time period is to be capital T, but here already one t is to be there, and that's why we are not taking as a capital T for the time period. Here notation is only different, but the meaning is to be the very important. The time period t is we know that it is inversely proportional to the frequency, and that's why this t is equal to small t is equal to 1 by n is to be there. So now again we are aware about that what is n. So putting the values of 1 means I have to do one thing, that is 1 by n, putting these values for the equation number 3 by 1 by this n value is to be there. If I put these values for this t is equal to there, then I will get this t is equal to, this will go upside and it will become twice pi, and under root of m by t will be there. So this is how this time period new relation I will get as far as the string is going to be concerned. So here the t is nothing but to be twice L under root of m by t is to be there. Again, if we go for in detail what type of the material you are using, according to that this t or the frequency is also going to be changing. Means suppose the what type of the string material you are using, either you are using a single rope, then this vibration will be different. If you are using the rubber, the vibrations will be different. If you are using the metal तार जर यूज केली तर ह्याची व्हायब्रेशन्स वेगळी राहतील. जर दोरा यूज केला तर त्याचे व्हायब्रेशन्स वेगळे राहतील. जर तुम्ही या ठिकाणी स्ट्रिंग म्हणून जर रबर यूज केलं तर त्याचे व्हायब्रेशन्स वेगळे राहतील. म्हणजे मटेरियल बदललं तर त्याची फ्रिक्वेन्सी पण बदलणार आहे आणि टाईम पिरियडसुद्धा त्यानुसार बदलणार आहे. आणि म्हणून त्या ठिकाणी जर समजा मला इन डिटेलमध्ये आणखीन जर समजा फ्रिक्वेन्सी आणि टाईम पिरियड स्ट्रिंगसाठी जर कॅल्क्युलेट करायचं असेल, that I have to put these important parameters into it. That is, if d is the diameter of the wire, here is the factors which are again responsible for this frequency and the time period is to be there. And the important factor is the d as a diameter of wire. Whatever be the, again the important thing why it is to be diameter, जर ह्याची डायमीटर चेंज झाली तर ह्याची म्हणजे जवळपास थिकनेस वाढायली, थिकनेस वाढली तर व्हायब्रेशन्स कमी येतील, थिकनेस जेवढी कमी राहील तेवढे व्हायब्रेशन्स जास्त मिळतील. मग त्यानुसार व्हायब्रेशन्स कमी जास्त मिळाले, फ्रिक्वेन्सीवर फरक पडणार. त्याचनुसार टाइम पिरियड इज ऑल्सो टू बी देअर. अँड दॅट्स वाय द डी इज द डायमीटर ऑफ द वायर if suppose we are considering, and rho, that is nothing but to be the density of the material of the wire. This is also very important factor. What type of the material you are using, the density of that material is also to be playing important role in this your frequency and time period is to be there as far as string is going to be concerned. So again, putting these values for the m is nothing but to be giving you the substituting the values for this m is nothing but to be pi d square by 4 into rho is to be there. So this is value for the your m, where the you are putting this relationship m is equal to pi d square by 4 into rho is to be there. As far as the modes are to be there, the whatever be the pi, that is the complete one, this is what the calculated for one complete period, that is why it is to be as in pi comes here, and then 1 by 4 pi by 4 pi relationships are comes here. So substituting these values in equation number 4, that is what the frequency we calculated, that will become to be as an n is equal to 1 by twice l into under root of 4t by pi d square rho is to be there. Now look at this equation carefully. What we are doing, the m is going to be replaced with pi d square by 4 into rho is to be there. So rho is outside, it is only pi d square by 4 is to be there. So here is the equation. If you look at this, is what the relation. And m, if I am putting these values for n, you have calculated, here is the n, 1 by twice l under root of t by m is to be there. T is to be there under root t by m. So m is going to be replaced. So m is having the value pi d square by 4 into rho is to be there, and that's why this 4 will go to the upside, and that's why this will become as an this value is to be there. m ची जी काय व्हॅल्यू आहे ती m ची व्हॅल्यू काय, पाय डी स्क्वेअर बाय 4 इंटू रो आहे. मग m च्या जागी जर मी ही व्हॅल्यू पुटअप केली, तर तिथं जर समजा मी पुटअप केलं ती व्हॅल्यू m ची, ही m ची जी व्हॅल्यू इथं जे पाय डी स्क्वेअर ही जर व्हॅल्यू पुट केली आणि बाय 4 जे आहे, बाय 4 म्हणल्यावर ती जाईल वर, अँड दॅट्स वाय इट विल बिकम 40, आणि म्हणून इथं काय झालेलं आहे ते 40 बनलेलं आहे. अँड हिअर दॅट्स वाय इट इज बिकमिंग टू बी ॲज एन, सॉरी, हिअर इट इज टू बी ॲज एन दिस इक्वेशन इज टू बी बिकमिंग टू बी ॲज एन हिअर 40, म्हणून इथं 40 आलं इथं. So 40 under root of 40 divided by pi d square into rho as it is to be there, and this is what, again here the whole thing is not to be completed. आता अंडर रूट 4 आहे म्हणजे त्याचं जर अंडर रूट 4 जर असलं तर ते येणार 2, मग 2 by 2 that will get cancelled. Then again what is the part, it is to be again having 1 by d square is to be there. डी स्क्वेअर अंडर रूट त्याला जर बाहेर काढलं तर इट विल कम टू बी एज एन डी, म्हणजे हा डी सुद्धा बाहेर येईल. म्हणजे बाहेर येणारा पार्ट काय, हा डी, आणि हा 2 आणि अंडर रूट 4चं 2 हा कॅन्सल होऊन जाईल, आणि रिमेनिंग पार्ट मग काय होईल, हा झाला कॅन्सल, आणि हा मग हा डी स्क्वेअरचा काय होईल, जर बाहेर आला अंडर रूटपेक्षा तर अंडर रूटच्या, तर तो होईल डी, म्हणून इथं काय आलं 1 बाय डी एल आलं, इंटू अंडर रूटमध्ये कोण राहिले, टी बाय पाय रो इज टू बी देअर. So that's why the frequency will be coming to be in this case is nothing but to be n is equal to 1 by dl into under root of t by pi rho is to be there. So this is what the exactly the frequency as far as the string is going to be concerned. This one was the very short or the very small point for this unit is to be there. And according to that, if we calculated the frequency here, the time period, you know that it is 1 by n is to be there, inversely proportional to this. So guys, I am happy to say that this first unit is going to be completed today. So what we learn in this unit, that is quite interesting. The first thing, fundamental waves. What is mean by waves, that is very much important, that will useful for the throughout the your semester. So waves, wave velocity and the particle velocity, in that we have seen what exactly the difference in between the wave velocity and the particle velocity is to be there. Again we have seen the differential equation of wave motion, second one, that differential equation of wave motion we have calculated. Again we have seen energy of a plane progressive wave. If the wave is going to be traveling, in that case how much amount of energy is going to be there. Again, we have seen the what will be the equation of the vibrating string is to be there. That is the equation of motion of a vibrating string is to be there. And today's last point was to be there, which is to be frequency and the time period for the your vibrating string is to be there. So as far as the your previous syllabi is to be there and this year's syllabi is to be there, the changes are made. I already sent you on the group that what is exactly our new syllabi is to be there. This year, from this year, the syllabi is little bit changed, and the one point which is going to be the velocity of the vibrating string is removed from the your first unit. So be carefully watch the what exactly the syllabi is to be there, and you can use my previous year's notes for this, but be careful while using that notes, the what points are there exactly for your syllabi you must see carefully. So as far as this part is going to be concerned, view is going to be concerned, I want to continue that second one, but I want to finish this video with the completely as and with the first unit, that is to be as and views is to be there. So those who missed my previous sessions, you can see my uh, previous videos already on my channel, that is with the name Satyajit Chauhan, and logo is very important. You can see with that you can search me, and either you can take from the your friends, and syllabi also I already sent on your group. And those who miss, don't miss that fundamental things about the waves that are quite interesting and very much important to understand what is mean by the waves. So guys, till then, from my side, thank you very much. And again, the as we are going through the very panic situation little bit over, and still be safe and be at home. Thank you.